Hello and welcome to the last edition of the Connected Hydraulics web seminars this year from the Heart of Hydraulics here in Lower Main. My name is Stefan Lehnert. In the next 45 minutes I will present you the topic together with our expert concerning system safety in manifolds. Now it's also time to bring our expert into the discussion. Hello, and it's a familiar face, you may remember him. Hello Marvin.
Hi.
Great to have you back. It's almost 1 year that we talked about HSR manifolds and functional setup. Today you focus on the topic of system safety, and we talk about a specific range of products, right?
Correct. Today, maybe first of all, also warm welcome from my side. My name is Marvin Mehling. I'm the responsible product manager for industrial manifolds, and today we will first of all try to build up a common base on the functional safety in hydraulics, and afterwards we will present our newest member in our manifold products family, the so-called STO manifold.
Okay, and that means safe talk off. That's what I already learned. For those of you that are maybe not too deep into the topic of machine safety, I think it's also very much driven also in Europe and Germany. I know that's what I also saw. But I think it would be still worth to invest some minutes to, let's say, have a first step into the topic, explain a little bit what's behind that, and then we will go. And again, as always, I would like to have you to have some application examples, so not only talk about the product itself.
Of course. So thank you, Stefan. Yes, functional safety in hydraulics usually doesn't matter if we are an OEM and try to build a machine, or if you're an end user and try to retrofit a machine. Anytime we are building a machine, we come to the point of risk analysis and risk assessment of this machine. So we have to get aware of what can happen in terms of personal safety. Can anybody stumble and fall? Can anybody reach out his arm into a dangerous zone of the machine? And what can we do about this to try to eliminate or reduce the risks and hazards that we have within the machine? And if when we are in the process of risk reduction, we have several options. First of all, we try to design a machine as safe as possible, meaning if we are able to prevent risks at all with, for example, a fence where I cannot get my arm through, then this will be the first level of solution. Second level of solution, and this will be our main focus for today, is a technical protective measure. According to different norms, we are capable of using, for example, a light curtain that, if it's activated, gives a signal to an electrical control that afterwards will try or will activate or deactivate valves, cylinders, in order to stop the motion within the machine or the risk within the machine, and like this try to make the machine safe. And all of this can be summed up and calculated in a so-called performance level. So how high is the risk of one dangerous failure within a certain time? And last but not least, a measure of user information. So the last option is, for example, to have information, wear your safety glasses to prevent dangerous situations. And this is, of course, in response of the operator at that point. But if we now concentrate on the functional safety side and the performance level topic, then we often or always have the topic of trying to identify the required performance level to make the machine safe. And this can be done with a so-called risk graph. So we're going through the risks that we have and try to identify, do we have serious injuries if something happens, or like reversible injuries? How often does the worker step into the dangerous zone of the machine? And is there the possibility of avoiding this hazard depending on the machine. And like this, we come to a required performance level in level C, D, or E. And this in the end determines how much effort we have to bring into the machine in order to make it safe.
Mm-hmm. So I think, well, this was kind of a very good and picturesque description of, I would say, a complex topic, but thank you for that already. I would like now bring you in and have a question to you, because we want to understand on what level you are in this topic. So first question would be, how often are you facing issues with machine safety in your systems? So is it something that you basically deal with every day or every project that you have, or is it something you think about once a month, once a year, or is this something that never occurs in your business? Which would surprise me, but let's see. Okay, so we have about 100 participants. 1/3 has voted yet, and it looks like half of the people that have voted have it with every project, every machine, and then declining once a month, once a year. So still, I think not everybody is dealing with that every time. So I think it would be interesting to see that. And the follow-up question would be, what challenges and hurdles do you face in the context of machine safety? We have a multi-select here. So you can select all these possible answers, like identification of hazards or safety measures, determination of the level. Yeah, we learned there are some different performance levels, and also proof of safety of performance level. So this may take a little more time to answer. Let's see. Okay. Now, quarter has voted already. Identification of safety measures and functions may be a part. And then the rest is kind of balanced, I would say, even the determination of performance levels. So I already know about the possibilities, and it looks like you have caught already a good broad range of interest. Let's see. Now, talking about safety as a topic, I think there's even more to learn about. We have even a web seminar we will talk about later on that we've done already. So we won't go into that too deep. We'll now switch a little more to the products and to the manifolds that you are responsible for. So STOM, Safe Torque Off Manifold, is kind of an individual product group you are now setting up, right?
Correct. It's a whole new product family, and we will try to explain it from the system side.
Okay.
So, for example, if a customer has a larger or even central oil supply, then usually we have different machines or machine sections that should be individually hydraulic controlled. And the STO manifold acts as an area shutdown to interrupt this hydraulic pressure supply from the volume flow, also from the pressure side. And in the end, with this, try to fulfill or help you fulfill your requirements on personal and machine safety according to the norms that are there, the ISO 13849 and up to category 4 and performance level E.
Again, category 4, so performance level E, I understood this is the highest possible. What about category 4?
So different performance levels can only be achieved if you have a certain system architecture within your system, meaning that, for example, one valve to shut off the manifold is not enough to reach the highest performance level. So the category describes that we, for example, need 2 of the valves and both of them monitored in order to fulfill the performance level E, that, as you said, is the highest level of safety that we can reach in the functional hydraulics.
Okay.
If we go on, now what does the manifold do? The STO manifold, as we told, is able to fulfill a safe torque off. Safe torque off is, of course, an electrical term, and in hydraulics we would maybe call it safe energy separation, meaning to cut the flow of the fluid, to cut the volume flow, the pressure of the system, meaning we cut it off from P1 to P2. And as a sub-function of this STO, we also have a SDE function within the manifold, meaning a safe decompression. So the P2 line will automatically be also decompressed to the leakage port. Our North American colleagues may know this as plug and bleed function. And last but not least, we also have the option to use the manifold as a safe limited speed, or because we don't have a cylinder here, use it as a safe limited volume flow function. So in the end, we will help fulfill personal and machine safety requirements according to the current norming situation.
So I think you already got the feeling that we have the right person, and even if we have engineers in the line, I know that you are full of answers, but we don't have any questions right now. So please use the chat, use the possibility to ask questions during this web seminar, and we will try to answer them. So talking about the products, now I said, let's maybe give an example. I think you prepared one example. What kind of applications are you focusing here?
Yeah, giving more pictures. I think the main applications would be, as I said, central oil supplies, testing areas, metallurgy plants, really where we have volume flows higher than 200, 500, or even 1,000 liters a minute.
Where hydraulic really is fun.
Yeah. Definitely. And if we look at that, the task is that we usually have different machine parts within the whole area or within the whole plant. So the STOM enables us to block these machines or machine parts individually. And by that, we are capable of blocking, for example, machine part A, while machine part B is still operating. In machine part A, we can do a safe loading or unloading, a safe maintenance, or even retooling the machine, while, as I said, the machine B is still operating. And this, in the end, doesn't only give us machine safety, but also increases or can increase our system availability.
Okay. Before we go into the system setup, I think you want to now show the different phases and how it contributes to the benefits. We also would love to ask you two more final content related questions. So the first one would be concerning safety functions, which would you say appear typically in your system? Also here it's a multi-select, and we have talked about them. You already invented them. Safe stop, safe torque off, safe de-energizing or decompression, and limited speed or volume flow. How would you say, what is your focus topic? Okay. Also again, 1/4 already voted, or it looks like safe torque off basically is the thing to do. Closely followed by safe stop and energizing, and yeah, it's kind of balanced again. Thank you. And the last question concerning the levels, maybe you have thought about it. I saw that 20% said it's hard to identify the level, but if you have, what would you say, what kind of level is, basically what you would need, which required performance level concerning safety function is relevant for your work? And it looks like we have a clear, okay, it's changing a little more, but still PLD, I would say, performance level D, it's kind of the majority, but then we will see it's kind of mixed between C and E. So a little different to Germany. I think here the topic is a little more focused, but still quite high. Yeah.
Yeah, very good feedback, definitely.
I think, you will see there's also here we will relate to in a second. Okay, now, you would say from a typical system setup, you will go through now the phases of functionalities. So you will start basically, I would say, with the idle state or the...
Yeah, definitely. So we are hydraulic people. So we also would like to understand the product from its schematics. What you can see here is the schematic of a STO manifold capable up to category 4 PLE. On the upper side, you will see the two main valves, active logics, called LC2A in our language. And on the lower side, we have two more size 6 valves to do a bypass function. Of course, in the default state, all of them are de-energized. The spool monitorings are active and giving a signal. And I marked it in different colors. From the P1 side, we will have pressure that is used to also close the valves safely, while the P2 side is decompressed to the leakage port, and that's actually the default state. And if we want to start up the system, we usually have a topic in bigger and central oil supplies. We have big dead volumes, long pipes with bigger diameters, meaning just opening the main valves will give us hard switching strokes. That's why we implemented the bypass functions, that if we activate, when we activate both of the bypass valves, we are capable of doing a pre-compression of the P2 line, meaning we slowly build up the pressure within the P2 until we have the same pressures in P1 and P2, and only afterwards we will start up the main valves and therefore the system. And this in the end gives us the possibility to damp switching strokes, and by this trying to increase the system lifetime of our components, and of course it will have reduced noise. To show you this in real life, we also brought a video from our test bench where we tested our manifolds before start of production, and that's what we want to show you now in the next and short video. So what you can see here is our STO manifold in size 32. In the beginning of the video, we just do the hard open, and you hopefully were able to hear it. It did a massive sound and a switching stroke on the hose on the right side. Afterwards, we decompress and do the pre-compression mode. Afterwards, we just open the main valves, and the switching stroke is a lot smaller if we watch it again.
Yes, you saw it moving.
So a lot less movement, and in the end, you have to imagine that we worked with 300 liters a minute and 10 liters of dead volume. In customer systems, metallurgy applications, we have dead volumes of several dozen or even 100 liters, which will increase the stroke, of course.
Could even be more effective.
And therefore, these pre-compression functions are very, very important in central oil
I like it also
supply.
visually, could really see the amount, or the, let's say, the level of noise, but also the deepness of movement. And yeah, so this was decompression, and now we go to the free flow state. I think this is full throttle, right?
Of course, full throttle. So after we did the pre-compression, we of course want to have the free flow. Therefore, we open the two main valves. They are fully opened, and then we can go through the manifold with full volume flow. Doesn't matter if it's 300, 800 or 1,000 liters a minute. So what's important at that point, of course, energy efficiency. With our STO manifolds, we work with the latest valve technology to really have the most energy efficient operation. You can see the flow characteristics for each size of manifold. So our manifolds are not only available in one single size, but in different sizes to fulfill the required volume flows in your system. Meaning on the lower side, you can see the one in size 30 and 40 with active logics, and on the upper side, you can see the smaller manifolds with unlockable check valves in size 20 and 30.
What is the typical flow area? Is this the gray ones?
I think typical flow areas will go from 200 up to 1,000 liters a minute.
So have a look at 1,000.
Presumably,
centipede do you have?
with 1,000 liters a minute, we will have around 12 bars of pressure loss with our active logic valves. Now, what's special here? With our active logic valves, we work with the newest series, meaning we not only have a standard hole, but it is more like a long hole, and therefore gives you energy efficiency increases of around 30%. That's a lot. Wow. If we think of the volume flows that we have here.
So that's already really impressive. Also, I think I like the idea or the demonstration of the sound difference, and the movement obviously is a lot better for the system. So already a lot of nice efforts and benefits, but still we haven't talked about safety too much.
Correct. Of course, if we now really put our hand into the light curtain, we come into the fail-safe mode. Before we do that, I will have to add one information to also give you an easy integration into your system. We solved the manifolds from the design side with P1 and P2 in one single axis. This gives you the possibility to have an easy and quick installation from the hardware side, and also from the electrical control side. All of the manifolds, doesn't matter what size, are solved identically. So once you have the code to operate the manifold, you can double it, doesn't matter what size you have. And now we come to the fail-safe mode and look at that from the schematics. So if I put my hand into the light curtain, all of the valves will directly be de-energized. This means the two bypass valves go into default state and will directly decompress the P2 line to the leakage port. Secondly, the main valves will also be de-energized, and they will not only shut down passively, but they will be actively pushed from the P1 to close as fast as possible. And this is very important to have not only a safety function that fulfills a performance level, but to really have the performance to shut down the machine as fast as possible. And during the development project, we somehow started with 500 or 600 milliseconds of closing time. We are now at a point that actually for any operating mode, we reach closing times of below 300 milliseconds. And the best thing is, the higher the pressure, the faster the manifold will close because of the LC2A valves.
So it helps. So the one effect helps the other. That's what I understand.
Definitely. The higher the danger is, the faster our manifold will react, which in the end gives the safety that we need as workers within the plant.
After this phase, we will start again with the default state, right?
Correct. After this, we are back in default state. All of the valves are monitored. P2 is decompromised, and the worker can actually try and go into the machine to do his job and to do his job safely.
Okay, that's good. Now we said let's have an information about the performance level required, and we saw it's kind of focused on D. E and C was also mentioned. I think what you present here, we said it's very high level, performance level E, category 4. Not everybody needs that. Is there anything for the other people that do not need the highest level?
Of course, we also made our thought about that. So if we look at the different levels of performance, we just explained the manifold with the category 4 and performance level E, but the manifold with the exact same drilled block is also capable of fulfilling a category 3 and performance level D. How do we do that? It's just simply the bypass valves are not monitored directly, but we have a pressure sensor within the measuring port of the P2 side. And by this, we are capable of doing a cyclical test of the bypass valves, and therefore save some effort on the monitoring, but still be safe with a performance level D in the system. And if you actually do not need the bypass function to pre-compress or decompress the system, then you can also go with the, let's say, base function and some cover plates on the size 6 valves. So you will just have the STO function, and that's it.
Okay, so you offer basically a broad range of different safety levels and applications in that case. So when you say this is a new product group or a product family, how many real products do we have behind that? I understand these are kind of standardized, so you can order them. They will be able to be ordered after the go live, but just what is the range of the portfolio?
Well, actually, it's not too much. So if we look at the variants of material numbers, then it's quite easy to pick a STO manifold. So first of all, we need to know a fluid, and therefore what sealing we can use. I now chose NBR, and I chose the size 32 because we stick to the example of 1,000 liters a minute. And by this, only 3 numbers will be left, and then I just have to think of, do I want to have the decompression and compression function or not? And do I want to have it in performance level E or in performance level D? And like this, you will come out with one single material number, and that's it.
Okay. And well, this is basically part of the data sheet that is not available right now, but you said to me yesterday it's in preparation. When would you expect to have it available?
Well, the data sheets are actually finished. They are currently in translation, and as soon as we have the English translation, and if we made our corrections, because all of the functional terms are difficult to translate, then we will upload it directly. I assume this will take either mid of December or maybe beginning of January.
So if you're lucky, you will get it as a Christmas present. I think you highlighted also some advantages. Obviously, a lot of hurdles that we asked for now dealt with. I would say if I pick, for example, the definition of the level, but also the risk assessment. So there's a lot of knowledge already inside the development, and just by picking based on the requirements that you have, I think you already have a lot of knowledge that you don't have to set up in your company.
Yeah, correct. We not only have the benefits of the product itself, but also the benefits of standardization and pre-work that we did with the product now. So if you're in the process of risk reduction and you need a manifold that fulfills this performance level for this safety function, then you just pick it and you're finished. I think you cannot be any quicker compared to trying to find the right valves, starting to build a bill of materials, schematics, designing the manifold to, in the end, inquire the manifold and get a quote after what time, a week or 2. So we are way faster with that. We reduce our own, or we are more efficient in our own sales, but also the customer is more efficient. Yeah, and in the end, maybe even better availability, because we have the same drill block for all different kinds of performance level, and the documentation gives the customer information before he even brings up the inquiry to us.
So standardization, I think, always leads to possibilities, and also the lead time and pricing maybe. Before we go on, I just saw questions coming in. Just the last question, data sheet you said available maybe this year, but latest earlier next year.
Yeah.
Online catalog, I think you will set up a new group for these products. The material numbers will be found, the documentation on the data sheet level. You even said the manuals.
Definitely, we will have a separate manual just for these manifolds, so that the electrical control of the manifolds is clear, how to operate the manifolds, and try to understand the signals, the monitorings, and when we should have which signal to have a safe operation.
And we know engineers on the line, they're also interested in CAD models, CAD files, so there will be also 3D CAD models. Okay, so in the meantime, we had several questions. So starting with a question from Peter Nilsson. Why different connections of the logic valves, A to B and B to A?
Well, actually easy answer. We made up our simulations, and in general, A to B, and again, A to B would be the most energy efficient operation mode. But by simulating via CFD simulations, we noticed that ABBA actually gives the same energy efficiency, and you have a differentiated flow.
Okay.
Therefore, you can be more safely in some cases, and the manifold design just gets more compact. And by that, we can also solve the P1 and P2 in the same axis. So yeah, there were more advantages for this version instead of going ABAB.
So you put in the experience of simulation to that. Annika had a question. Hello, do you have larger sizes than NG40?
Not for now, but if higher volume flows are necessary, meaning a LC50 or LC60 version, this is no problem to scale up the manifold to the size that is required by the customer.
Okay. Then would it be a great choice to implement these kind of manifolds if we care about efficiency and energy costs?
Well, yes.
Easy answer.
Yes. If we're in safety, we have to fulfill the safety regulation. Otherwise, we won't be allowed to operate the machine or to sell the machine. So we have the necessity to solve these safety regulations. In the first place, this will bring additional pressure loss we wouldn't have if we wouldn't have the safety function, but we have no choice. But still, of course, it is important to have as safe, as energy efficient operation as possible. And this is what we did with our newest high flow logic valves. And therefore a clear yes.
And you said already in the one phase that you have high energy efficiency ratings here. Even I think the calculation here is also talked about costs, something that we're doing already online with our Size and Select, for example. So it would be also possible to support the customers with the calculation of their TCO cost and on energy side.
And in the end, we have volume flows between 200 and 2,000 liters a minute. If 10 bars is too much for any customer, you just have to pick a size bigger. Then you will have 3 or 4 or 5 bars of pressure loss. And if this is okay, then we just go one size higher to fulfill the energy efficiency requirements.
And as I know that you have prepared also some FAQ, frequently asked questions, I'm really happy about the last one because here it's already been written, will these manifolds be certified?
Well, maybe I should jump to the last slide.
We can keep it. You just
okay.
A verbal comment on that?
Yes, presumably. We are currently in the process of having these appointments and talks with the TÜV Association. So in the best case, by the end of February, we will also have a official certification for these manifolds.
So we will have the final questions in some minutes. We just will conclude, but if you have further questions, bring them in. We have some more minutes left. So now these are some advantages just by picking the data sheet using the right. So could you maybe sum up as a final result, what are the overall advantages of this application, of these possibilities?
We really talked a lot about the personal safety as well as the energy efficiency topic of the manifolds. We also have additional benefits. For example, if you have special fluids in your metallurgy application, if you need an HFC or HFDU fluid, we are able to fulfill this with the right pilot valves. We have a leakage-free shutoff from P1 to P2. the design of the manifold is really, really compact. And in the end, by the standardization, we profit from, reduced project planning and design. We have a faster development. You as a customer have a faster development. And in the end, also a optimized supply chain, thanks to a fully and assembled, tested control block.
So I think on one page you see basically why you should think about the solution, and I think that's already for the moment. I think it was a good insight, starting with some basic know-how, talking about the STO manifolds. We have nice application examples. I like this noise example, and at the end I think we went through every phase and found several benefits that are combined here. I would like to say thank you for the moment. I think that's just what I wanted to say. We will, of course, give you the information to this web seminar in a written form to your, let's say, registration. You will receive that, but even more online. You see already there's tons of information, like the landing page input on the manifold side. We have the article from the EuroBLECH, one of the biggest fairs in this section, where you will get the data sheet and the manual at least earlier this year, maybe even before Christmas. Then what we mentioned, the web seminar on functional safety, it's already 2.5 years ago, but there's a lot more insight concerning this topic if you're interested. And yeah, the most important thing is on the lower right corner, you can contact Marvin in case of questions or interesting projects. Of course, your local sales representative in the country would be to go first, but if there's some specialist questions, not everybody can know everything in our sales unit, even if they're excellent. You can even connect with Marvin on just to stay updated, because obviously there will be some more. And I heard next year there will be the official go live, so all the best for
Correct.
that. I think we already found today there's huge interest in this product. You had a good feeling about the market needs. And yeah, before we go into the end, I would say you already said you have prepared some more questions. So as there are no more questions coming in the chat, so what else would you like to talk about?
I think some of them came already up. So if any one of you is interested and needs a manifold with an STO function, are they available already? Well, the official SOP, start of production, will be together with uploading data sheets, manuals, and really going live with the product. If you have an application and you need a quote, of course, we will support you in preparing an offer, and in the end, of course, offer a STO manifold to our customers. So yeah, sales has actually started. So we kind of called it by that. Can I get a safety calculation? Maybe this is a more typical German or European question, but maybe it's also necessary in North America. When we have to prove our performance level of the whole function, we often need a so-called Systema calculation that proves our safety level. And of course, if a customer is interested and they decide to go for a STO manifold, we are also able to provide these calculations. We did all this during the development project, and therefore we can also give it out to our customers.
Volume flows, we had a question already, I would say.
Correct.
Possible we can outside of the range.
We can scale up, but we can also scale down, so both is possible.
Certification, the question already come in.
And yeah, fluids were also answered. So actually, very good questions from our audience.
Good to have you online. I think we reached the right people. That's what we thought, but maybe you can give us your feedback as a final setup. We have, as usual, some feedback questions for you. If you were satisfied, if your experience would have been set. And for me, just the last information. This is, as I said, the last web seminar for this year. We will go into winter break together with you at the end of the year. And then in February, there will be the next web seminar where we'll talk about high performance pumps with colleagues from our pump department in southern Germany. So I'm looking forward to welcome you there if you're interested. So again, thanks for you. Thanks for your appearance.
Thank you,
I hope I hope I will see you again. It's always fun doing this with you. And also, I would love to see you during next years, and hopefully you have a good ending of the year. We all keep up with the last weeks, and I'm sure you're also quite busy. So thanks for your time. Thanks for joining, and yeah, see you then. Bye-bye.
Bye-bye.